Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Rotational Symmetry Never 10 by Railman, and here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once in every row, column, and box. Box here. We have German whisper lines, where adjacent values along a green line must have a difference, a difference of at least 5. So for example, if this were say a 3, this would have to be an 8 or a 9, because those are the only digits which are 5 or more away from 3. And that's an example of how German whisper lines work. We also have killer cages, where digits in a cage cannot repeat and must sum to the total shown in the top left corner. So, for example, these two digits must add up to 13. So if this were, say, a 5, this would have to be an 8 to add up to 13. And that's an example of how killer cages work. And finally, we have rotational sums cannot be 10, which is why rotational symmetry never 10 is the title of this puzzle. That means all digits in the grid have a 180 degree rotational opposite. So for example, the 180 degree rotational opposite of this cell would be this cell down here. So these would be rotational opposites. And every digit in its rotational opposite never add up to 10. So for example, if this were say a 4, this could never be 6, because then these two would add up to 10. And that would break that rule set. He gives examples here. So for example, row 1, column 2. So if row 1, column 2 is a 4, then row 9, column 8 cannot be 6. So this could not be a 6 here, because that's rotational symmetric. If row 5, column 4 is a 7, then row 5, column 6 cannot be 3, because they would be rotationally opposite of each other here, and therefore they can't add up to 10. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the only digits adding up to 15 are 6 through 9. Also, on a German whisper line or a whisper 5 line, as I like to call them, you'll always alternate between high digits, which are 6 through 9, and low digits, which are 1 through 4. So since this is 6 through 9, it's guaranteed to be high. And the reason why we know that is because if you have what digits can be next to a high digit, 6 through 9. If it's 6, it's only 1. If it's 7, it could be 1 or 2. If it's 8, it's 1, 2, or 3. And if it's 9, it's 1 through 4. But those are all low digits. And you have the same knowledge for high digits. So this must be low and this must be high. Well, these 3 digits are all next to this digit here, which means these 3 must be the same set, must be different sets than this one, which means they are the same set here. So this must be all lows, which forces this to be a high. This is low because it's only 1 through 4 add up to 5. The high digits must be next to low digits. The low digits must be next to high digits. So these are high. That's next to low digits. So these are low, which must be next to high digits. So these are all high here. This set is different from that one, but this is different from that. So these 3 are the same. They cannot be high digits, so they must be low digits, which forces all of these to be high digits here. Okay. Let's see. This digit is next to 3 unique digits on a whisper 5 line. And it's high, so it must be 8 or 9, right? 7 can only be next to 2, so this is also 1 or 2 here. But these cannot add up to 10, interestingly enough. This is next to 2 unique digits on a Whisper 5 line, so this is 1, 2, or 3. So is this, so this must be 1, 2, or 3 also. This is next to 2 unique digits on a Whisper 5 line, so it's 7, 8, and 9. But if we had this be 7, 8, or 9, well, actually, that's not true. Okay, this could be 6 through 9 here. We're not sure. This digit is next to 2 unique digits on a Whisper 5 line, so it must be 1, 2, or 3 here. We have 4 high digits in column 3. That means the rest of the digits cannot be high. So these are 1 through 5 here. We know 5 is one of these digits. 4 is one of these digits. This has to be 4 through 9 in box 5 because of the 1, 2, 3 triplet here. This is 1 through 4 here. This is next to 2 unique digits on a Whisper 5 line. So are these. So this has to be 7, 8, or 9 here. This must be, this is next to 2 unique digits. This is next to 2 unique digits. So this is 1, 2, or 3 as possibilities. Because 4 is the only low digit, which can only be next to 1 unique digit on the Whisper 5 line. And 6 is also the same one. So this technically could be 1 through 4. Okay, rotationally. So either this is 3 in box 5, which means it's next to 8 and 9 only. So this is 8 and 9. Or this is 3, which makes this both 8 and 9. That means the rest of box 5 cannot contain 8 or 9 because we're guaranteed one of them's here and one of them's here. These cannot add up to 10. These cannot add up to 10. These cannot add up to 10. Okay. We don't have very much information there. Okay. If this is 3, this has to be 8, 9, and 8. Okay, so if this is 3, this is guaranteed to be 8, 9, and 8, 9. But that would force this to be a 7. And then 3 and 7 would add up to 10, and they're rotationally opposite each other. So this cannot be 3. Therefore, this must be a 3 here, which forces this to be 8, 9, and 8, 9, which eliminates 8 and 9 in the rest of the box. This 3 cannot be next to 7, or cannot be rotationally opposite a 7, so this must be a 6, which forces this to be 1 and this to be 1. That eliminates 6 in the rest of the box. This 1 forces this to be 2 here. 1 cannot be rotationally opposite a 9, so this is 8, which forces this to be 9. The 2 can only be next to 7, 8, and 9 on a Whisper 5 line. So this is 7, 8, 9. This can't be 8. That leaves this digit as a 6, which can only be next to 1 on a Whisper 5 line. So this cannot be 1 here. This can't be 1 here. 9 can be next to 1 through 4, so any of those are still good. This can't be 1, this can't be 3, this can't be 3 because of the 3 here. This 6 eliminates 6 here, so this can't be 9, because then that would add up to 15. So if this were 6, that would force us... If this were 9, that would force us to be 6, which is not possible. We are guaranteed one digit from 7, 8, or 9 in this 12 cage, right? Because you have either 3, 9, 5, 8... Sorry, 3, 9, 4, 8, or 5, 7 here. That eliminates 7, 8, and 9 with these two cells in the rest of row 6. So this cannot be 7. This can't be 7. So this must be 1, 3, 4, or 5 here. Again, this could be 3, 9, 4, 8, or 5, 7 there. 3 can only be next to 8 or 9 on a Whisper 5 line, so this must be a 9, because 3 is next to 8 and 9 here. Where is the 5 in column 3? It has to be here, so this cannot be 2, 5. It's either 1, 6, or it's 3, 4. So we're guaranteed a 5 here. This 1 eliminates 1 here, so this cannot be 4, because if that's 4, that would force a 1 there. We know 1 has to be one of these digits here. This cannot be 4, 9. It's either 5, 8, or 6, 7. Either way, we are guaranteed one of these is 7 or 8. This, along with the 7, 8, 9 pair here in box 4, eliminates 7, 8, and 9 in the rest of the box. So this cannot be 7, 8, or 9. It must be... So we're guaranteed a 9 has to be here, so this cannot be 9 here. This can't be 1. It could be 2, 3, 4, 5, and 6 possibilities. Okay. This 9 eliminates 9 here, so this can no longer be 4, because 4 can only be next to 9 on a Whisper 5 line, so this is 2, which makes this 3. 3 can only be next to 8 and 9 on a Whisper 5 line, so this is 8, that's 9. This can't be 2 or 3, so this becomes a 4, 5 pair, which eliminates 4 and 5 in the rest of the box. So this can't be 3 or 4, this is a 1, 6 pair, which eliminates 1 in the rest of the row, so this can't be 1. This is 2 or 3. That means this can't be 6, so this becomes a 7, 8 pair here. Which means, and this can't be 7 or 8. It can't be 6 because it's next to 2 or 3, so this is guaranteed to be a 9 here. This is 2 or 3, so this cannot be a 2, 3 pair because that would eliminate all possibilities for that cell here. So this is 1, that's 4, which eliminates 1 and 4 in the rest of the box. This 3 eliminates 3 here, so it's 2, which means this cannot be 2. So this is 1, 4. This is 3 or 4. This 8 eliminates 8 as a possibility here, so this can't be 5. This can't be 4 because of 4 in the column, so this can't be 8. Okay. This is 9. Okay, that doesn't have anything rotationally symmetric. Remaining digits in row 3. We have... Well, where is the 1 possible in column 7? Cannot be here because of the 1, 6 pair in the row. These are all filled out. Cannot be here. Cannot be here, cannot be here, so it can only be here. So this is 1, guaranteed. Remaining digits in column 7 are 3, 4, 5, and 6. But 6 cannot be here. 4 can't be here. 6 can't be here because of 6 in the row. 4 can't be here because 4 in the box. 6 can't be here because of the 1, 6 pair in row 8. So where's 6 possible in column 7? It has to be here. Okay. Remaining digits in box. This is 6 and a high. But the rotationally opposited is here, and therefore cannot be 4 because that would add up to 10. So this must be 5, which forces this to be 4. So that's low. This can't be 5 anymore because of the 5 in the row. We have a 3-4 pair in column 7, which eliminates 3 and 4 on the rest of the column. So this can't be 3, that's 5. Okay. This cannot be 6 because that's rotationally opposite 4. So this must be the 1. That's 6. This is low. This is high. This cannot be 8 because if it's 8, that would be rotationally opposite the 2, and that adds up to 10. So this is 7, which forces this to be 9, which makes that 8. Therefore, this must be a 6-7 pair, which eliminates 6 and 7 in the rest of the box and the rest of the row. So this can't be 7. Where's the 7 in box 5? It has to be here. So that's 7. This 8 eliminates 8 here, so it's 7 and 8. This cannot be 5-7 or 4-8. Therefore, it's a 3-9 pair, which eliminates 3 and 9 in the rest of the row and the rest of the box. So this can't be 3. This is 4. That makes this 3, which makes this 2. 4 eliminates 4 here. This can't be 1 because of 1 in the column. So that leaves the 1 in row 6 to be here. 6 eliminates 6 here, so it's 7 and 6. These are both high. This is low. This cannot be 3 because it's rotationally opposite that, and that adds up to 10. So this would be 9. That's 3. So this is low. This is high. Okay. Remaining digits in row. We have all the lows in column 8. So that leaves 5 through 9 remaining. This can't be 5 or 6 because of 5, 6 in the box. So 5 through 9, 5 through 9, 5 through 9. This can't be 8 or 9. This can't be 8 or 9. This can't be 9. Where's the 9 in column 8? It has to be here. So this is 9 and a high. This can't be 6 or 7 because of the 6, 7 in the row. This can't be 7 or 8 because of the 7, 8 in the row. This can't be 7 because of the 7 in the row. We have a 5, 6 pair in column 8, which eliminates 5 and 6 in the rest of the column. This can't be 5, that's 8. This can't be 5 or 6, so it's 7. So this is high, this is high. That leaves this as 4, 5. This cannot be 4 because of the 4 in the box. So this is 5, which makes this 4, which makes that 5, which makes that 4. This can't be 2 because of the 2 in the box. This becomes a 3, 5 pair. This 5 eliminates 5 here, so it's 6 and 2. 6 eliminates 6 here, so it's 5. Okay. Remaining digits in box 3. We have what? 3, 7, 8. This can't be 3 or 8, so this must be 7, which makes this a 3, 8 pair. Remaining digits in row 3. We have 4, 5, and 6. Okay. This can't be 6 because of 6 in the column. This can't be 6 because of 6 in the column. So where's the 6? In row 3, it has to be here. Remaining digits in column 9. We have 1, 6, and 4. 1 can't be either of these, so 1 must be here. Therefore, 6 can't be here because of the 6 in the row, so this is 4, that's 6. Okay, since this is 6, this cannot be 4 because that would add up to 10, and those are rotationally opposite, so this is 5, that makes that 4. Okay, remaining digits in row 8. We have 7, 8, 9. This can't be 8 or 9, so this is 7. This can't be 9, so that's 8, which makes this 9. Okay. Okay. What's the easiest one to tackle? Let's go column 2. We have 2, 3, 5, and 7. 7 can't be either of these because of the 7 in the box. Can't be either of these because 7 in the box, so it has to be here. So this is 7. We have 2, 3, and 5 here. 2, 3, and 5 here. This can't be 5 because of 5 in the row. Remaining digits in box 1 are 2 and 4. 4 can't be here because of 4 in the row, so this is 2, which makes this 4. 5 eliminates 5 here, so it's 3 and 5, so this cannot be 5 here. Remaining digits in column 1, we have 8 and 9. 8 can't be here because of 8 in the row, so this is, oops, not there. This is 9, and that's 8. Remaining digits in row 7. We have 2, 3, and 4. This can't be 3 or 4 because of 3, 4 in the column. So this is 2, which makes this 3, which makes that 2. And therefore, this is 4. Okay. Remaining digits in row 9. We have 3, 5, and 6. So 3 and 6 cannot be here because of 3, 6 in the column. So this is 5. This can't be 6 because 6 in the column. So this is 3, and that's 6. Remaining digits in column 4. We have 3 and 5. This can't be 5 because 5 in the row. So this is 3, that's 5. Remaining digits in column 5, 1 and 8. This can't be 1 because of the 1 in the row. So this is 8 and 1. Remaining digits in column 6 are 2 and 7. This can't be 7 because 7 in the row. So that's 2, that's 7. 3 eliminates 3 here. So that's 8 and 3. And that's a solution. Let's just double check. 4 and 1 add up to 5. Excuse me. 6 is next to is 5 away from 1. 1 is 8 away from 9. 9 is 6 away from 3, which is 5 away from 8, which is 6 away from 2. 9, 8, 7 are all 5 or more away from 2, which is 6 away from 8, which is 5 away from 3, which is 6 away from 9, which is 8 away from 1. 5 away from 4, 7 away from 2. 1 is 6 next to 6 and 1. 8 and 9 are both greater, 5 or more greater away from 2. 1, 4 add up to 5. 3, 9 add up to 12. 6, 7 add up to 13. 1, 6 add up to 7. 7, 8 add up to 15. Again, 4 and 1 add up to 5. 7, 7 add up to 14. 6 and 9 add up to 15. 3 and 3 add up to 6. 1 and 5 don't add up to 10. 2, 6 don't add up to 10. 5, 4 don't add up to 10. 9, 2 is 11. 8, 8 is 16. 3, 6 is 9. 4, 1 is 5. 6, 5 is 11. 7, 7 is 14. 8, 9 is 17. 5, 8 is 13. 1, 3 is 4. 9, 2 is 11. 2, 4 is 6. 5, 6 is 11. 8, 5 is 13. 3, 8 is 11. 9, 4 is 13. 4, 2 is 6. 6, 1 is 7. 2, 7 is 9. 1, 3 is 4. 7, 9 is 16. 5, 1 is 6. 8, 4 is 12. 1, 8 is 9. 9, 2 is 11. 3, 6 is 9. 4, 5 is 9. 2, 7 is 9. 6, 3 is 9. And 7, 9 is 16. 3, 2 add up to 5. 5, 6 add up to 11. 9, 4 add up to 13. And 8 and 1 add up to 9. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.